Okay, what I'd like to show you now is how to solve some equations. They're going to be two-step equations, and we're going to solve equations that involve fractions. The last video just went through solving equations with integers. Now we're going to work through solving with fractions, and I'll probably show you two different methods to solve these. So this equation, 1/5 m minus 1/2 is equal to 3/4. Like I showed you the other day, one thing that helps some students is to go ahead and draw a line down from the equal sign. And we know that on the left-hand side of the equation, I have my variable term and I have a constant. On the right-hand side, I just have a constant. So let's take this constant, or this term of negative 1/2, and move it over to the other side. As I mentioned before, it's minus 1/2. The inverse operation is to add 1/2, or when you jump over that equal sign for a constant, you change the sign. So on the left-hand side, negative 1/2 and positive 1/2 are additive inverses. So you are left with 1/5 m. And on the right-hand side, if you get that common denominator, 2 times 2 is 4. So you need to take the numerator times 2 as well, because 2 over 2, you're multiplying by a value of 1, which just remains itself. So 2 times 1 is 2. 2/4 is the same thing as 1/2. And the first fraction just remains as 3/4. 3/4 plus 2/4 is 5/4. Add the numerators, keep the denominator the same. Now what we are doing in this particular problem, or at this point in this problem, is you're taking 1/5 times m, and that's equal to 5/4. So the inverse operation of division, or the inverse operation of multiplication, is division. So we're going to divide by 1/5, which is what we did in the previous problems with integers. It's just now that I have a fraction. But instead of putting the bar over here, let me write it with a pencil. Instead of showing it as 1/5 here, because what people like to do is they like to say divide by 1/5, keep, change, flip, and they flip the wrong fraction. So to eliminate that possibility of flipping the wrong fraction, I like to excuse me, have you write this down on the right-hand side as divide by 1/5. So now that it's in this format, you can go ahead and do your saying of keep, change, and then flip. So then as you go ahead and solve that, you are going to find out that 1/5 divided by 1/5 is 1. So you get m is equal to multiply your fractions, you multiply the numerators together, and you multiply the denominators together. So m is equal to 25/4. Now if you wanted to, you could check yourself. 1/5 times m, which we said was 25/4, minus 1/2 is equal to 3/4. So when you solve that, you are going to find out that 5 goes into 25 5 times, so you have 5/4. 1/2 is the same thing as 2/4. And if you subtract those, you do get 3/4, which goes to show you that m equals 25/4 is the correct solution. Okay, example 2, this is the same problem that you just worked through, or the same exact equation that you worked through. And we know in algebra, legal moves are whatever you do to one side, you have to do to the other side. So if you're not a fan of fractions, that's okay. We can get rid of the fractions. What you need to do to get rid of the fractions is you need to look at every single denominator on both sides of the equation. And when you look at 5, 2, and 4, what is the common denominator? Well, the least common multiple between 5, 2, and 4 is 20. So if I multiply both sides of the equation times 20, this is going to help us get rid of the fractions. Now on the left-hand side, let me draw that line down from the equal sign. On the left-hand side of the equation, if we look at it, we have 20 times the quantity 1/5 m minus 1/2. So when you have that, you're going to have to use the distributive property. when you use the distributive property, you need to take each term times 20. So there's the setup of our problem, and from here what we want to do is just go ahead and multiply. We're going to take 20 over 1 times 1/5, which is 20/5, or 5 goes into 20 4 times, so you are left with 4m. The next fraction, if you take 1/2 times 20, you get 20 over 2, which reduces down to 10, or 2 goes into 20 10 times, so we get minus 10. And on the right-hand side of the equation, some of you want to put that as 64s. I like to reduce because this is 20 over 1, so 4 goes into 20 5 times. 5 times 3 is 15. Now to me, this purple equation looks a lot better than working through this red and blue process that we did up above that involves fractions. All we had to do is multiply each term, both left and right-hand side of the equation, by the common denominator. Now we go ahead and solve this problem. So I want to isolate the variable term. So I'm going to move this negative 10 over to the other side. Instead of subtracting 10, inverse operation is to add 10, or change the sign when you move it over. So negative 10 and positive 10 are additive inverses, which leaves you with 0. So you have 4m on the left-hand side, and on the right-hand side you have 25. And then as a final step, what we're going to do is we're going to divide both sides by the coefficient of the variable. So we're going to divide both sides by 4 because the inverse operation of that multiplication is division. So if I divide by 4, m is going to be equal to 25. That's not writing very well. M is equal to 25 fourths. And that is the same answer that we got before when we worked through it with fractions right up here. And then we went ahead and we substituted that back into the equation to prove that that was a true equation. So I'm going to give you just a couple more examples that deal with those fractions. Okay, so here's another fraction problem. So if you go ahead and draw your line down from your equal sign, I'll work through it first as fractions. So we have a variable and a constant on the left-hand side. We want to isolate that variable. So we're going to move 3/10 over to the other side. If you change the sign, or inverse operation of subtraction is addition, so we're going to add 3/10 to both sides. So additive inverse, negative 3/10 and positive 3/10 is 0. So we end up with 2/5 x is equal to, get your common denominator, which is 10. So you have 3/10, and 5/10 is the same thing as 1/2, or you got to multiply by 5 over 5. 2 times 5 is 10. Now if you add those, you end up with 8/10. Now you could reduce that to 4/5 if you wanted to, or you can just wait for the next step in order to do that. So the next step, as you look at it, you're taking 2/5 times x is equal to 8/10. Inverse operation of multiplication is to divide. So we're going to divide by 2/5. Remember, when you write division by 2/5 on the right-hand side, I want you to show divide by 2/5 so that you get your keep, change, flip correct, so that you invert or take the reciprocal of the correct fraction. Now I like to reduce my fractions. Some of you are going to say it's 40 over 20, which is 2. That's okay. 2 goes into 8 4 times. 2 goes into 2 once. 5 goes into 5 once, and 5 goes into 10 2 times, so you're left with 4 halves, or you can go ahead and reduce that, and your answer is that x is equal to 2. And you could check yourself if you wanted to. But the next thing I wanted to do is show you how to solve that same exact problem, but to solve it by getting rid of the particular fractions if you're not a fan of fractions. So we have 2/5 x minus 3/10 is equal to 1/2. Now the common denominator between 5, 10, and 2, the least common multiple is 10. So we're going to multiply both sides of the equation times 10. And when you multiply this left-hand side of the equation by 10, what you need to do is you have to use that distributive property, which means I'm going to take each fraction times 10. So if I multiply the first fraction times 10, 5 goes into 10 2 times. 2 times 2 is 4. So we have 4x. 10 goes into 10 once. So 1 times 3 is 3. So we get 4x minus 3 on the left-hand side. On the right-hand side, 10 times 1/2 is 10 over 2 or 5. Or you could say 2 goes into 10 5 times. So you are left with the equation 4x minus 3 is equal to 5. Now we want to move the 3 over to the other side so we can isolate the x value. The inverse operation of subtraction is addition, or when you jump over that equal sign, you got to change the sign. So you have additive inverses with 3 and negative 3. So you are left with 4x, and on the the right-hand side, 5 plus 3 is 8. And then as a final step, the inverse operation of multiplication is to divide. So 8 divided by 4 tells you that your solution is x is equal to 2. So 2 different methods to solve. One, you're working with fractions. The other one, you're getting rid of fractions. And I don't care which method you use. Okay, for this last example, the only difference with this problem is that you have a mixed number as one of the terms. So the first thing you want to do is change that mixed number into an improper fraction. So you take the denominator times the whole number and add the numerator, because you remember you're taking whole parts or whatever and you're breaking them into fourths. So 4 times 2 is 8 plus 1 is 9, so you get 9/4 x plus 3/7 is equal to 5/14. So to solve, we need to move this 3/7 or the constant over to the other side. So instead of adding 3/7, we are going to subtract 3/7, or you change the sign. So on the left-hand side, you have additive inverses, and you are left with 9/4 x. On the left or the right-hand side, you get a common denominator of 14, so you need to multiply it by 2. So negative 3/7 is the same thing as negative 6/14, and you have 5/14. Now this is the tricky one, because as you look at it, you look at the 5 and the 6. The 6 is negative, so team negative wins by 1. So you get negative 1/14. Now the next operation, since this is multiplication, you get rid of it by division. So you're going to divide by 9/4. Remember, on the right hand side, show the division bar as the bar with the 2 dots. We're going to divide by 9/4. So it's negative 1/14 times, keep, change, flip, 4/9. Now you can reduce, so go ahead and multiply those. 2 goes into 4 2 times, and 2 goes into 14 7 times. So what you are left with is x is equal to negative 1 times 2 is negative 2, and 9 times 7 is 63. Now if we want to, real quickly, what you would do, because I'm going to run out of time here, is take that fraction where you have 9/4 x plus 3/7 equals, that's a 5/14. So that common denominator is 28. So I'm going to multiply each fraction times 28. Sorry if I'm going a little quick, but I know I'm going to run out of time. 4 goes into 28 7 times, so you get 63x. 7 goes into 28 4 times, so you get plus 12 is equal to 14 goes into 28 2 times, which 5 times 2 is 10. So you're going to move the 12 over to the other side by subtracting it, and you get 63x is equal to negative 2. Team negative wins by 2. And then divide by that coefficient of x, which is 63. So x is equal to negative 2 over 63. I will get a decimal one created here for you in a moment.